So it's a pleasure for me to have the opportunity to talk to you today about mammalian social evolution, summarizing several papers and projects published over the last years, which you can find here if you also look there. So there's a great biodiversity in social systems in mammals. Some of the species are solitary living, others live in pairs, and there are different kinds of group living. And to understand this biodiversity, we are following the concept by Peter Kappeler, who says that social systems have four main components. The first one is social organization with 6 different categories. They can be solitary living, pair living, or different kind of group living. The social structure, how individuals interact with each other. For example, do they have pair bonds? Yes or no. Are they territorial? Yes or no. And so on, with at least 8 subcategories. The care system who is taking care of the offspring with 6 subcategories, though in mammals the first one does not exist. And the mating system who is mating and reproducing with whom, again 4 subcategories. And the different number of different kinds of combinations of all these subcategories of the 4 components of social systems shows us that way more than 1,000 different forms of social systems are possible. So to understand this diversity in comparative studies is very difficult, and because of this we focus here on only one component, which is the social organization. It means the composition of social units, how many males and how many females are there per social unit. And we've been asking, what is the ancestral form of social organization of different mammalian taxa and of all mammals? And it's generally believed that the ancestors of mammals were shown here in red, solitary living, and also the ancestors of most mammalian orders, that they were solitary living, with the exception of elephant-shrews, macrocelidae, and artiodactyla. Let's assume that they derive from a pair-living ancestor. So why are we asking this if this is already kind of known? Because it is rather believed than known, as previous databases that did comparative studies assumed data for hundreds of species that were never studied. So they just assumed small nocturnal species are all solitary living, and from this assumption find that the ancestor was solitary living too. And they did not consider intra-specific variation in social organization. So for many years, with many students from different labs, we composed a database of high quality based on only primary literature and only on field studies without any assumptions. That means we only looked at real data, only at species that really have been studied in a natural environment. And we took intra-specific variation in social organization into account. We did not put one social system per species. For example, if a species, there were 8 pairs and 2 groups observed, we said the main social organization is pair living, but with some variation of 20% that is explained by group living. We found altogether data for 1,622 populations from 806 species. There's a bit more than 5,000 mammal species. About 1 out of 6 mammal species has been studied in the field for the social organization. The first study we did is descriptively on Eulyptotyphla. So these are the shrews and the relatives, formerly called insectivores, where hundreds of species and other databases have been assumed to be solitary living, but in fact only 16 of these species have really been studied, and most of these species were actually group or pair living, and only 7 out of these 16 species were solitary living. And from this description, it seems that a pair living ancestor is as likely as a solitary living ancestor. In Artiodactyla, we had a larger data set with data from 100 species, and we then used the Bayesian approach, Bayesian statistics, where if so was included as one category of social organization. And we found, like had been predicted by others before, that the ancestor was pair living, but with some variation. For macrocelidae, the elephant-shrews, it was assumed that all elephant-shrew species are pair living. We found that at least one species is only solitary living, and that several species can be also pair or group living, but still the ancestral form was pair living with some variation in it. For monotremes and Xenatra, like expected, we found, but only with descriptive studies, that the ancestor was most likely solitary living. But even in platypus, there have been quite a number of reports of den sharing, which have often been ignored because the species must be solitary living, but there might be more social tolerance than typically assumed. And even in Xenatra, the sloths and armadillos, it was found in some cases pairs have been observed. Finally, not finally, but from the orders, finally, the primates, where we have the largest database with 215 species. And here we used if so, not as an additional category, but as an independent continuous variable, saying how many percent of the social units deviated from the main form of social organization. And interestingly, we found that the ancestor of all primates was pair living with some variation. It's best explained by solitary living, but only about 15% of the ancestral population was solitary living, and most of them were pair living. And that's important because there have been many studies trying to explain the evolution of pair living in primates, like in titty monkeys, owl monkeys, callitrichids, and so on. But if we see that pair living is actually ancestral, it might change the view we also have of primate social evolution and of all mammal social evolution, maybe in total. When we look at, there's still one missing, are the marsupials. Of course, we're here in Australia. So in the marsupials, it's also believed by many people they're all solitary, and the ancestor was solitary living. But from the species where we found data, a lot of them actually are pair or group living. And we did not find that solitary living, though it was the most likely ancestral state, it was not significant. There was a lot of variation. It is also best explained by pair living. So there's much more ancestral pair living than has so far been believed. And then when we look at all mammals, it's about 200 million years ago when they evolved, we find in a preliminary analysis that the most likely ancestral state is solitary living, but with variation. It's best explained by pair living, about 20 to 40% of the social units pair living. So quite similar to the primates, but in primates, the main social organization is pair living with solitary living as some variation. Here it's the other way around, mainly solitary living with pair living as some variation. And so what is outstanding and what we still have to do is to analyze it for placentas. This is 200 million years ago. This is 80 million years ago. This is about 70 million years ago, to see what would be the ancestral state here. Now, it might be surprising that mammals are not per se solitary living from the ancestral state, but often pair living, because it's often assumed your primitive mammals are solitary. But when we look at the paleontological evidence, it's maybe not as surprising, because already for ancestors of mammals, cynodonts living 200 million years ago, there is fossil evidence for pair or group living, as is there for early mammals 75 million years ago, and for mammals 60 million years ago. If you add to these paleofacts paleopoetry, and we look now at a potential ancestor of all mammals, that's a Brachydurus mammalian that lived about 10 million years ago. This species was nocturnal, it was small, insectivorous, had a short gestation period with large litters. It was burrowing, probably had a nest within a burrowing site. And from our comparative studies, it could, at least some of them could form pairs. And here this is not known, but this is what I could assume, is that they were territorial. And because they were eating insects, their territory could not support too many adults. And when they're territorial, there might be especially territorial against same-sex conspecifics, males against males, females against females. And interestingly, because of the short gestation period in early mammals, males could much sooner increase their fitness by paternal care than is in extant mammals. It's often argued mammals cannot be pair living and show paternal care because of the long period of pregnancy, but this was not such a good argument for very early mammals. And when we look at this, some of these ecological and life history factors, like being small, being insectivore, having a central nest, possibility to form pairs, being territorial, especially against same-sex conspecifics, they would very much resemble what modern songbirds are doing that are pair living with biparental care. And like small songbirds, early mammals were endotherms with high energetic costs, and they're especially high for small mammals because of a high surface ratio. They're more likely to lose heat, and we know these days that small mammals especially benefit from group living because of social huddling, reducing energetic costs. And if it's true that they were territorial mainly against same-sex conspecifics to find a partner to warm each other at night and save energy, if males hate males and females hate females, the only possibility was to form pairs, maybe within the nest inside these burrows, and then possibly even show paternal care. So to conclude, comparative studies on social evolution in mammals, they are changing from a solitary perspective to a more sociable, maybe pair-living perspective when we base our analysis on data derived from field studies and when we consider intraspecific variation in social organization. Mammalian social systems are flexible and most mammals are social. Only 25% of studied mammals are actually solitary living, and thus solitary living in mammals might be a derived state representing an adaptation to specific environments. It might be an adaptation or not a primitive ancestral state. We still have a lot to do for analysis with our large database, but I'm not a specialist in these analyses, and we're currently looking for somebody who is very good in Bayesian statistics and comparative analysis to join us, maybe as a postdoc willing to apply for Marie Curie Fellowship, or permanent researcher who might want to collaborate. There's also some funding opportunities. If you're interested in this, and please come and talk to me or send me an email. Thank you very much for your attention. So.